In Chapter 10, we're going to be looking at hypothesis testing and how to ask and answer questions about a population proportion and use statistics to do that. So we need to understand how to translate a research question into a statistical hypothesis, then also understand what rejecting the null hypothesis implies. That should be a rejecting. And that if you reject the null hypothesis, it implies strong support for the alternative hypothesis. And if you fail to reject the null hypothesis, it does not imply strong support for the null hypothesis. Okay. So that is a little bit of a strange concept for people to get usually, and we'll talk about that. We want to make sure that we know the two types of errors that are possible in a hypothesis test and understand how the significance level of a test relates to the probability of a type 1 error. And finally, we want to understand the reasoning used to reach a decision in a hypothesis test. Okay. So first of all, we'll learn techniques for testing a claim. In the article, Boy or Girl, Which Gender Baby Would You Pick? This article summarized a study that was published in a fertility and sterility magazine. This article makes the following statement: when given the opportunity to choose the sex of their baby, women are just as likely to choose pink socks as blue socks, a new study shows. So in this original study, we had 1,385 women were sent a 19-question survey. Of the 561 surveys returned, 229 women said that they would like to choose the sex of a future child. Of the 229 women, 140 chose to have a girl. So first we think about what is the population of interest. Are the 561 women who responded to the survey representative of that population? Okay, so the population of interest would be women, right? Who may be pregnant women, and is this a representative sample of the population? Does the high non-response rate pose a problem? Remember, they sent out 1,385 surveys. Only 561 surveys were returned, and that actually is pretty consistent with what happens when you send out surveys. So the sample proportion, 140 out of 229, is 0.61. Is that consistent with a population proportion of 0.5, where 0.5 would choose, half would choose to have a girl, half would choose to have a boy? Is p hat equal to 0.61 due to sampling variability? Right? So those are the things that we're wondering. Is that, it looks like 61% said that they would choose to have a girl, and is that different than 0.5? Half the people choosing a girl and half the people choosing a boy. Is that due to sampling variability, or is observing a sample proportion as large as 0.51 very unlikely if the population proportion was actually 1/2? So a hypothesis in its simplest form is a claim or a statement about a value of a single population characteristic. Okay, that's all a hypothesis is. It's just a claim or a statement about one thing. So the following examples are hypotheses about population proportions. We could say P is less than 0.25. And what that says, if we're talking about, in this particular case, P is the proportion of email messages that included an attachment. we would say that less than 25% of the email messages sent included an attachment. If P is greater than 0.8, where we're talking about P as the proportion of email messages that were longer than 500 characters, our hypothesis says that more than 80% of the email messages sent were longer than 500 characters. And finally, if we had a P that was equal to 0.3, where P is the proportion of email messages that were sent to multiple recipients, we would say 30%, because it equals, it's not greater than or less than, it equals 30%. 30% of the email messages sent were sent to multiple recipients. Okay, so that's your statement about a population proportion, or your claim. Okay, so what is a hypothesis test? A hypothesis test uses sample data to choose between two competing hypotheses about a population characteristic. So if your hypothesis is 30% of the email messages sent were sent to multiple recipients, then we could have a competing hypothesis that said it's not 30% of the email messages sent were sent to multiple recipients. Okay. So it's just two different claims that are competing with each other. There's opposites of each other in a sense, okay, about a population characteristic. So suppose that a particular community college claims that the majority of students completing an associate's degree transfer to a 4-year college. You would then want to determine if the sample data provided convincing evidence to support this, that a majority of the students completing an associate's degree transfer to a 4-year college. So that means that what they're saying is that that percentage, P, is greater than 0.5, because a majority means that it's more than half. So to test that claim, we would set up two competing hypotheses. One that says that it is half, and one that says that it is greater than half. Now, you could also do less than or equal to half, but one of them has to have the equal sign in it, right? So what we're going to do is we call the null hypothesis and we denote it H sub 0, because that sub 0 is in math called not or a null. Is a claim about a population characteristic that is initially assumed to be true. Then we have what we call the alternative hypothesis. The alternative hypothesis is denoted H sub A, and sometimes in some statistics books, or if you look up anything online, you might see H sub 1, and that also means the alternative hypothesis. It's just to kind of keeping in line with the H sub 0 for the null hypothesis. But in this textbook, we will use H sub A for alternative hypothesis. So when you have these two competing claims, there are two possible conclusions that the hypothesis test can give you. You can reject the null hypothesis, and you can say what we used to believe to be true, we really don't think is anymore, right? We're rejecting that. Or we can fail to reject the null hypothesis. Notice that we never actually say that we're going to accept the alternative hypothesis. We are just saying that what we believe to be true maybe isn't, or what we believed to be true maybe is. Okay, so in carrying out a test of the null hypothesis versus the alternative hypothesis, we reject the null hypothesis in favor of the alternative hypothesis only if the sample data provided convincing evidence that the null hypothesis is false. Okay. The conclusions are always made about the null hypothesis, not about the alternative hypothesis. Okay. So, how do we write these null hypotheses? Okay. Hypotheses. Okay. Also, if the sample data do not provide such evidence, then H naught, or the null hypothesis, is not rejected. And hypothesis statements are always made about the population characteristic, not the sample statistic. So when we write them, they will look like this. The null hypothesis, we write H sub 0 colon the population characteristic equals the hypothesized value. Okay, so if we're talking about the proportion, we would say the proportion equals, I don't know, 0.5, something like that, right? That's what it would look something like that. Okay, so one thing that we want to remember is that the null hypothesis always includes the equals sign. The alternative hypothesis could be a greater than, a less than, or a not equals to. So this would look like H sub A, the population proportion, is greater than 0.5. Or maybe the alternative hypothesis was that the population proportion was less than 0.5. Or finally, that it was not equal to 0.5. Okay. So, things to note. The alternative hypothesis uses the same population characteristic that says characteristic. I know you can't read it. And the same hypothesized value as the null hypothesis. So the hypothesized value, the hypothesized value, like what I wrote over here, was 0.5, right? The hypothesized value is a specific number determined by the context of the problem. And also the sign is determined by the context of the problem. Okay, so let's consider a murder trial. Okay, what is the null hypothesis? Well, in this country, you are presumed innocent until proven guilty. So the null hypothesis is that the defendant is innocent. That's what you go into believing in if you were a juror on the trial. What would the alternative hypothesis be? That the defendant is guilty, right? So the null hypothesis is what you assume before the trial begins. Now, before you begin your statistical test, it is what you assume to be the case. If there is not convincing evidence, then we would fail to reject the null hypothesis. Okay? So, this is where we have to really think carefully about how we state things. We never end up determining the null hypothesis is true. Okay? So we never say that the defendant is innocent, right? A jury finds a defendant not guilty. So we're never saying that the null hypothesis is true. We're only saying that there's not enough evidence to say that it is not true. Okay. So to determine which hypothesis is correct, the jury listens to the evidence. Only if there is evidence beyond a reasonable doubt would the null hypothesis be rejected in favor of the alternative hypothesis, and then we could say that the defendant was found guilty. Right? We either say the defendant is found guilty or the defendant is found not guilty. What we talk about is the alternative hypothesis, but it's rejecting or not rejecting the null hypothesis. Okay. So consider this example in a study. Researchers were interested in determining if sample data supported the claim that more than 1 in 4 young adults live with their parents. So the population characteristic that we're talking about is the proportion of young adults, proportion, not proportion, that live with their parents. What would the hypotheses be? Well, the null hypothesis, remember, is that what you believe to be correct, and the alternative hypothesis is something else. And we get that from the context of the problem. So right here it says more than 1 in 4. Well, 1 out of 4 is 25%. So we would say that the alternative hypothesis is that the proportion of young adults that live with their parents is more than 0.25. The null hypothesis would be then that the proportion is equal to 0.25. Now, again, some textbooks will say that because this is greater than 0.25, they will say that the null hypothesis is less than or equal to 0.25. Either one of these is okay. What's important is that we are using the population characteristic P, and that the null hypothesis has the equal sign in it, and it is a different claim than the alternative hypothesis. So yes, it is okay to write P is less than or equal to 0.25, but P equals 0.25 works just as well. Just fine. So how about this? A study included data from a survey of 1,752 people ages 13 to 39. The survey question asked participants how satisfied they were with their current financial situation. Suppose you want to determine the survey data provide convincing evidence that fewer than, that's a 10%. Kind of covered up the 10 when I circled the fewer than, of adults 19 to 39 are satisfied with their current financial situation. And this should have been 19 up here also, because, you know, who cares if a 13-year-old is satisfied with their current financial situation? Most of them don't really have a current financial situation. And we want to talk about adults because they're the ones that are actually in a position where they can change their financial situation. Okay, so we want to define the population characteristic. So the population characteristic would be the proportion of adults ages 19 to 39 who are very satisfied with their current financial situation. So when you're filling this out, when you're asked to define the population characteristic, you should always have, that should be a sentence, that should be out written in words, telling the reader of your problem what you're talking about. Now, your hypotheses could be in words also. It's fine to have the null hypothesis on the alternative hypothesis written in words. You don't have to always just write a mathematical equation, but you can. So we're talking about we wanted to see if there is evidence that that population proportion was less than 10% or 0.1. So our null hypothesis is that the population is equal to 0.1, or you could say greater than or equal to 0.1. Either one is fine. Actually, yes, fewer than. Okay. How about this one? The manufacturer of M&Ms claims that 40% of plain M&Ms are brown. A sample of M&Ms will be used to determine if the proportion of brown M&Ms is different from what the manufacturer claims. So what is the characteristic, the population characteristic? It is the proportion of plain M&Ms that are brown. And then we want to state the hypothesis. So we need a null hypothesis and we need an alternative hypothesis. So the alternative hypothesis, because it says it's different than 40%, and so the manufacturer is claiming that 40% of the plain M&Ms are brown. So the proportion is of brown M&Ms is going to be 0.4. That's our null hypothesis, right? It's what we believe to be true. So it's what the company has claimed is true, and what we want to do is we want to suggest this alternative competing hypothesis that says, you know what, it's not really. And it would be denoted by a not equal to. Okay. The alternative hypothesis would be that the proportion of plain M&Ms that are brown is not equal to 0.4. Okay. So now what we want to do is we want to just so that we are careful in how we write these, now that we've practiced writing a few, let's look and find errors in these. So go ahead and pause the video at this time and look at A through E and see if you can figure out where the error is. So we can see that C has the nice smiley face. So C is a null hypothesis and an alternative hypothesis that is written correctly. So take a minute, pause this, and go through and find the errors. And now we will go through and answer them. So for A, we have the null hypothesis is that P is equal to 0.15. There's nothing wrong with that, but when I look at the alternative hypothesis will never have an equal sign. So hopefully you saw that. It should just be P is greater than 0.15. In B, when we look at B, we see that we're using, or the person that wrote these hypotheses are using the sample population statistic, and the hypotheses always use the population characteristic. So you should never see those hats on our P's. Stick. Yeah. For D, when we look at D, we have the null hypothesis is P is equal to 0.23, and that looks perfectly fine. And then I look at the alternative hypothesis and it says P is greater than 0.32. And by itself, each of those look fine, except that when you put them together, the hypotheses have to be around the same number. So the number must be the same, or the value. And then finally, the last one, the null hypothesis always has the equals sign. So we can't, it looks like they've switched up the null hypothesis and the alternative hypothesis. In those. So just be very aware of those. They seem like really slight, tiny little things, but they are very, very important in statistics. And if you write your null hypothesis incorrectly or your alternative hypothesis incorrectly, you really can't do a statistical test to solve for that. Okay. So let's take a look at